Testing microphone. I hope you can hear me on the live stream. Testing. Test microphone. Test. We'll just wait for one more minute and then we'll get started. In the meantime, if there's any questions that is bothering anyone from the past lectures or anything about your current assignment, you can ask. I'll cover that today. Yeah, because it's just something very small, so yeah. Okay, so I think we can get started. So welcome to the second lecture of week 5. Today, we have some pending business from Tuesday's lecture. There were a few concepts that we couldn't demonstrate properly. So we'll start today's lecture with a little bit of recap of that. Apart from that, some reminders again. First of all, your Lab 5, which was supposed to be due on Friday, that is tomorrow. There's flexibility because we know that you had a very reasonably short week, 4 or 5 days to finish the lab. So you can submit that by Monday, and that should still be fine, right? In line with our normal Monday submissions for lab. Iteration 2, we'll continue discussing that during this lecture and moving forward as well till the time it's due. And I'll try to link the concepts that we introduce in every lecture and its relationship to iteration 2 or how it can be useful maybe in iteration 3. So we'll do that as we go along. Just a reminder again, there's a specific section which states that you have to have at least one commit per week, right? So just to avoid any penalty, please do that and make sure it's a quality commit. Don't just commit anything. Ensure that it's a quality commit. Also, from this week, you must have seen that a lot of our scripts are in TypeScript, right? So today, again in the lecture, a little bit of JavaScript, but we'll try to move towards TypeScript so that you get more familiar with the syntax. And likewise, iteration 2 basically requires the submission to be in TypeScript. Also, we are particularly focused and pay all importance to code presentation. So make sure you include the related libraries that I mentioned for code linting so that it's not only readable, but later on when you actually want to test the code, it becomes quite easy for someone to verify if the logic is correct as well, right? Apart from that, next week is Flexi Week, so you don't have to turn up for your lecture or your labs. You can basically use that time to catch up just in case you are behind on your lectures or your tutorials or your labs. Also, take that time to refresh yourself so that when you enter week 7, right, you come with renewed energy and motivation. So take that time out for yourself and also an opportunity for catching up. So like I said, no lectures in week 6 and also no assessments will be due in week 6, right? This lab that is due on Monday is pretty much just an extension of a week 5 deadline. And finally, we'll reiterate this important point just in case if you're experiencing issues with your group, because the amount of workload for iteration 2 and iteration 3 will be quite substantial. It is important to make sure that your groups are functioning properly. And for that reason, we are there to help you, guide you, and ensure that you are not unnecessarily overloaded or stressed. And if you're experiencing issues with members not turning up, dropping out, there's conflicts or uneven contribution, reach out to your tutors and we'll try to take note of that as well so that when we mark your assessments, we can take that into consideration. So those are the important announcements. And now before beginning with our proper lecture, we'll try to look at some of the things that are kind of pending. One was the persistence demo that we couldn't complete last Tuesday. So I'll complete that for you. Apart from that, there were some questions that students raised in the chat, which due to time we couldn't answer, or I couldn't answer. And then there were some questions also in the lecture, which maybe can benefit from a bit more clarification. One was about return types for functions in TypeScript. That is an interesting question. Can we have a return type, just like we have in C, C++, and other programming languages? Yes, we haven't seen it in the code so far, right? But what I'll do today is try to demonstrate some code that has the return type. So far, it has been implicit. So we just assume that a function will return certain value, and maybe the line of code that was invoking that function might pass things into the correct format as an integer or a JSON and so on. But this time around, we'll see that we can also explicitly have a return type in TypeScript. Now, for a normal function, it might be easy to see that. The specific question was about error functions. How do you specify the return type in an error function, that very shorthand notation we use, which was method 3. So I'll try to show that as well. How do we export functions? We have already learned this, right? But we know that we now have 3 ways of defining functions, declaring and defining functions. So how are the different ways we could export them? There was also this interesting question, how test cases are marked, right? What if you miss some test cases in your test file? So when we mark your test cases, we use a combination of human as well as scripts to test your test cases, right? And that concept specifically is focused on during today's lecture, which is on coverage, right? And we'll talk about how we could have, measure code coverage and test coverage. And then the last bit that we'll cover in today's lecture is in exceptions, right? Which is very common when you write code. There are situations where functions or even users, when they interact with the certain functionality of the program, may not provide the right kind of input, which can affect the processing of the function itself. So how do we handle those erroneous input and ensure that your programs don't crash, right? Because for a normal application on your local machine, if it crashes, maybe you are there, you can restart it. But for a real life situation, when your HTTP server crashes, right, thousands, if not millions of people get logged out of the platform, and it creates a chaos. So exception handling is quite important. So we'll look at some demonstration of that, and we hope that we cover all of this within today's lecture. Yeah, and the last bit is feedback. All these improvements or ways we are recapping things from past lecture is because of the feedback you provide. So use that feedback link QR code to provide us feedback, so that for the remainder of the 6 weeks, we could help give you a better experience. Not only for lectures, but also labs and also the course content and assessments as well. So feel free to provide feedback on those matters. Okay, so first of all, like I said, we're going to recap on where we left off last time. I'll just open my VS Code. Anyone has any questions for now? No? Okay, so let me see where I am. I'm in my user directory. Go to my documents. Okay, so I'll just use 5.3. Okay, so last week on, sorry, not last week, in the last lecture we are talking about persistence, right? And we know the value of persistence. For now, so far what we were doing is as soon as we stop our server, all the data that is generated basically is lost. So we don't want that to happen. If someone has added more books into our library, we are using the books example just as a continuation of what we have been seeing so that there's more familiarity. So if user adds more books, these books actually stay in the library so that when someone else visits the endpoint to query a book, they are able to retrieve that book as well. Even if the server is restarted because maybe it went through maintenance, still the data is persistent. So what we'll do is start with the old version of the code. Right? So this is the old version of the code where there's no persistence at all. So we use the array structure to have 2 books initially, and then every time the server restarts, regardless of what was deleted or added on the platform, we restart with 2 books. Now, if we want to ensure persistence, we discussed that there are 2 ways we could do that. One is through a proper database, which is the ideal way, but database is not a content or a subject that we're going to focus on too much in this course. So we'll use the most simpler way, which is using just a normal file, right? So in this case, we'll use a JSON file. So in order to use read and write functionality on Node.js, we'll just import a built-in library. We'll use the alias JS, file fs for file system, and we'll use this particular package, right, which is fs, right, for file system. So we have that. Next, in the existing code, what we'll do is we'll define where that file basically sits at. So const books file, right, equals, and we'll just specify the location. So let's assume it stays in this current directory with the name JSON. So if you see here, I don't have that file. Right? I had it for testing purpose earlier, and I have removed it. If you download the code from the course website, you might have that file. You can delete it if you want, right? If you are following step by step. Now, we have some existing books, right? What we can do is, if we have a file, we can read the data from the file, right? But if we don't have a file, we need to have some starting point, right? We can start with a blank slate, but what we'll do is just an easier approach. We'll check if the file doesn't exist. Let's just insert these 2 entries in the file, and then that becomes our starting point. So when we launch our server, the server will already have 2 books. It will not read it from the array. We'll just ensure it's reading those book information from the file, which will be possible through our script, right? So we'll call this array initial books. Remember, books array is used throughout the code, so we'll let it be separate, which is empty, right? Now we'll check if that books file exists or not, right? So if, let's see, exists, and we check this file, books file, right? Right? So that's our condition. If it exists, okay, we want to know the negation of that. If it doesn't exist, what we'll try to do is use this data and create that file. Right? Just a simple logic. If that file doesn't exist, we'll use this data and create that file. So to create that file, let's see, write to file. We already discussed why we're using write file in a synchronized way and not the asynchronous way in the last lecture. Now, we need to provide the file path. So, the file path, right, this time I won't make that mistake. So, this is the path books file. Right. And what do we want to write? We want to write this array information, right? Initial books. Right. So that should do it, but for some reason that is currently underlined. Right. That means TypeScript has detected some issue with the parameter that we are providing. Can you think of why it is under those red underline? Right. The reason is because that is basically an object we are writing, right? An array. That file is a JSON file, and it expects us to actually pass it as a JSON, right? Right. So now we have done that. Let's just run the code. Error, unexpected, okay, object not valid. What do you think could be the reason? Do you think this will solve the problem? So we do file system.write. We pass the file and we pass the data as a string, right? So as a string means stringify. Okay, now that works, right? So you have to just be mindful. Maybe I was rushing a bit, right? So it needs to be passed as a string, and that's why it was not writing it to the output file. Now books.json didn't exist before, like I mentioned. You see now it's created, and then the two items from the array has now been written to that file, right? Now you must be asking me, why did I put these additional parameters, right? I can get rid of this. Oh, sorry, I'm in some other part of the code. Get rid of this. Okay. Because I have changed the code on the server, for that reason only, I'm just restarting the server, right? Because it now has to run the new script. It's still working. Let me just delete this as well. Sorry. Okay, so what the purpose of the null and to is basically just to format the string in a more structured JSON format, right? At the moment, it's very raw string, right? If you want it to be neatly formatted with two spaces after the attribute and so on, currently it comes as a single line, normally a little bit difficult to maybe read for you. That's the reason for using this additional two parameters, right? Not mandatory, but useful from the readability point of view, right? So if this file doesn't exist, so let me delete. Let's run this again, right? Now that's done. Now let's see if we are able to retrieve that book information through our API client. Right, we just quickly use the get. I'm running it on port 3001 again today. Let's see. No entries. Okay, why am I not getting any results from my get? Anyone can take a guess, right? So I've checked that if I had any persistent storage for my data, okay, I didn't, so I created a persistence storage. The information is written to the books.json file. Now, if I want to do a get, I should read from the whatever my persistent storage is, right? And I haven't written the code to read. So if I look at my get code, right, it's reading the books array, which is still that empty array, right? So what I can do is that books should actually be equal to, and we read the file, and we have to provide the path and encoding, if you recall from last time, right? So the path is books file, and because it's a JSON file, then we use UTF-8, right? The different encoding schemes. I'll save that. I think the reason for this curly braces is because there's a few other reuse of that particular keyword or that particular variable in other files that I have, right? So I've done that here. Let me do the same for another get function which I have, right? Shouldn't be there. It should be right at the beginning, right? When I do get, and for here as well, books equals that, right? Now I've made changes to my code, so for that reason I'm restarting my server. I'll go to my API client. I get the results, right? But not in the ideal format, right? It is still readable because I have sent it in a formatted way for readability purpose of my file. You see now that those new lines, just to clean up the presentation of the data, is bothering us a little bit now when we want to read the data, right? Those /n means new line characters. We can easily fix that as well, right? What we can do is just pass that back to JSON. So what we'll do here is just stop the server for a moment. After reading books, we'll do JSON.pass. Right? So whatever we get, we pass it, and we do the same thing for the other get as well, right? So we read the file and we pass it as JSON. And there we go, right? So now our file is, our application is reading from persistent storage. If I delete an entry, right? So what do you think delete would do? remove that entry. Now things are not in the array. If you look at our implementation of the code for delete, it's removing or splicing it from the array. Now we are using persistent storage. We have to also make sure that that update is represented in the file as well, isn't it? So that's what we'll do now. We'll do fs.write file, right? In the synchronized way, we have to specify the file path, which is the books file, and we have to specify the data. Remember when we wrote to the file, we used the stringify function. So we'll just use that again, just for consistency. And then our data is actually this updated array of books. Right, Control C, and then run it again. This is our get. Let's make a delete, and we have two books, 1 and 2. Right, let's delete 1. Right. This time delete did not respond with any body. The reason is because we used a very simple logic. We either send an error, success message, right, or book not found only if it was deleted, right. In the send, there's no body or no additional information sent. That's why the delete did not show any output, right. So the file is deleted. We wanted it to update the persistent storage, so let's open our books.json, and now you see the file is deleted. Right. The reason it's now in this format is because I forgot to fully format the output, right. So null to, when I write to a file, let me just delete this again. So I've deleted the file. Let me start the server again. Right. So no file exists. File gets created because from the array entries. And then if I delete, you'll see that now it's deleted and nicely formatted in the right way, right, in a readable way. So that's how your delete will work. Now there are some other functions there like put, and also what's the other one? Post, right, when you create a new entry. Now how will you update your persistent storage in that case? So when you update some records, we are initially, before, what we were doing, we were just updating it in the array. Now we'll update or just write that information in the file. So we'll just use the write script, and then when we are deleting, we write it to a file. Let's see, when we are updating, that's a put, right? Success, we just write it to a file, right? Yeah. So we have to just update the books array. The other one is post. So when you create a new book is created. That can also go in the file as well after it's created. So not only pushed into the array, but also pushed into the file. So I'll save it. So now all our functionalities should be working, right? Our file only had one entry because we are using persistent storage, right? Now what I'll do is just use that as a guideline to do a put or do a post first, right? And then in the body, I don't have to provide the ID. I'll put the title of COMP1531. Let's say put my name and then 2025, right? And then it's JSON, and then the endpoint. Is this all okay? Looks okay? Right, so it says created ID 2, and if I now go back to maybe the get, right? So there's additional entry created. Now why is the ID 2 here? Well, it's a logical error in the implementation because it just takes the count of how many books are there and the next book takes the next ID, which is usually not the right way, right? You have to take the value of the ID and add it by 1, right? So I deleted 1, so there was already an ID with 2, but it just did the count and then did +1, so 1 item plus 1, 2, right? That's why it looks problematic. Let's do something else. Let's do an update, right? So let's, the problem is there's 2 books with the same ID, right? Which shouldn't happen. So I think the issue should be is here in the implementation. So when we do a post, yeah, it does length +1, right? So it should actually take the ID to be the highest value of the highest entry +1. So request body assign ID to array length. So how can I fix that for now? Okay, I could do books, and whatever is the length of the books, right, that element dot ID +1. Does it make sense? Right, so if the length is 1, then we take the length, that very first element, or should it be length -1? Because counting in an array starts with 0, right? Okay. Let's delete this. Okay, now we have a normal entry, right? 1 and 2. If we do a get, we get 1 and 2. And last time, remember what we did was we deleted book 1, right? So we were left with 2, which gave us that issue, right? So we have book item 2. Then we posted a new book, right? And now we get the ID 3, which makes sense now, right? So we're just using the last book's ID and just adding the next one, right? Now, if I just relist my books again, you'll see the next book has ID number 3. Now, if I want to update this, okay, I'll just use the same information here. Let's just change it to put, and ID is 3, and I'll just call it updated here, and then updated, and run that, right? So it seems to be updated in here while the program is running, right? But the good thing about persistence is that when you go back to the original file, it's also updated here, right? So next time when I run my program, suppose you stop the program, restarted the program the next day. So you made some changes already to your data. What you have done is you have deleted book 1, you have updated book number 3. So you'll see the new data here. Yeah, it's just not scrolling, something wrong with here. But yeah, ID number 3 is here too. Yeah. So that's the example of persistence and how it can be used. So what we have done is just a simple implementation which you can try. Now you'll see that a good programming practice is code reuse. So if you are, for example, writing in multiple places, there's a chance that you can make some errors. So what you can do is just refer to the persistence file, and you'll see I have created a read book function and a write book function, right? And then the rest of the places I have just reused the read book method or the function read book method in the get, and then in the post write books in the put, and write books in the delete, right? And the reason for that is just in case you want to change the way the file is written, if you want to change the format of the string, or if you want to, for example, change the encoding type, or you want to change the location of the file, is just in a few places you have to change the code, right? So that is about persistence. Any questions? No? Okay, so we'll close this chapter on persistence now and look at the other feedback that we got, and that is exporting arrow functions. Okay, so here you see that I have a function, right? If I want to export this function, quite straightforward. I use the keyword export, right? And in another file, whether it's my test file or something else, I can just use import sum, which is the name of the function, from, and I have to identify the location, right? So its location is in which file? Return type, right? And then I can do console.log sum of, let's say, 40 and 60. Right, so this is the function export. Let's clear this. Run this code. Right, and it works in another file, right? Quite easy. Option 2 is you do export and then sum, right? Save, come here. Let me change the values so that we know that it is actually working, and it does work, right? Now the question that was raised last time is, what if it's an arrow function, right? So what happens is when it's an arrow function, which is method 3, so transitioning from method 1, which is the traditional function declaration and definition, const sum equals function, right? So that's your method 2. That's your first class function where function get assigned to a variable so it can be passed on. So if it's method 2, something like this, not a problem. Here, if you call it, still by the name it works, right? And then obviously if that's the case, you can have your arrow notation here. Get rid of all these because there's a single return statement. So you have a function which looks slightly complex but is the same function, right? And then that's how it's exported. Right? And then 70. Right? And it works. So that was another question that was raised in the during the class, and I think in the chat as well. There was this third question about return types, right? So let's just go to this function in its original form. Yep. Okay, just double checking if it's still working. Sorry. Yeah. Okay. Now takes a number, two numbers in fact, and then returns the sum of those. So definitely the return type would be number. So in C++, C you'd probably define the return type here. In TypeScript, you just use the colon and put the return type. Yeah. Number, right? And then get the result. Maybe we'll look at a few other examples where we can change or play around with the return type. If it becomes an arrow function, nothing changes, it just still is the same, equals, you retain that return type there and get rid of all these unnecessary lines of code which your compiler does not need anymore, right? So this is what it looks like. So you have your function name, you have the parameter list with the data type and also the return type, followed by the arrow operator and the actual implementation of the function. Okay, so with that, we'll take a short break of 10 minutes, right? Before we move on to the two topics that we want to cover today, which is on coverage, which is important mostly for iteration 3, but there is some little bit of items from there which will be useful for iteration 2 as well. And we'll look at some exception handling. In the meantime, I'll probably just look through some of the questions on the chat. So there's a question about what's the benefit of using an arrow function? Well, first of all, an arrow function basically simplifies the number of lines that are taken up by the code. So it makes it more readable, first of all. And in a client server or a web-based environment, of course, you want to transmit less information over the network. You want the pages to load faster. So if you have less statements, smaller JavaScript files, it will load much more faster in the browser. That's the second advantage. The third advantage is, of course, because it makes it a first-class citizen function, an arrow function can be passed as parameters or returned by other functions as well. right? So it can easily be used in higher order functions. Yeah, there's this other question about what does JSON do again. So basically we use JSON parse basically in this book library. Because if you look at the structure of the data, right, the best way to store these different attributes, the best structure would be in a JSON format because it supports the key value combinations, right? If you use a CSV file, it's much more hard to manage. So that's why we opted for JSON. And because we are using JSON and our file system is reading those JSON files, then we have to pass the data when we read in and also pass the data or stringify the data when we write to the file. So that's the reason for using JSON format. Yeah. There's this other question here that I'm reading this file inside the if, right? So it won't be read all the time, right? Which is correct. So when I initially want to launch my server, if there's no persistence storage available, books.json, with some listing of books, it makes sense for me to read, first read or use the data in my existing array and write it to a file, right? So that we have something to start off with. However, next time if I restart my server after maintenance, because that file exists, I don't have to worry about this array which may be outdated, because from the point that array was read and written to a file, there might be many updates, edits, deletes to the data. So I need that persistent storage to be used as my input source. But initially if it doesn't existed, then rather than having a blank file, I'm just using this data to act as a starting point for my library. Okay. There's a question. Is there a reason why we're using more like a C style or normal standard style, a looping structure? You'll see in the previous lecture, I used the find index, right? So you can use that actually to retrieve the book from the persistent storage as well. This is just an alternative implementation of the same thing. So you can use a for loop to iterate through an element, or you can use the find index, which is correctly pointed out by someone in the chat as well. Okay, another interesting question. Is it truly persistence? Because we are using the array as an intermediate. Basically, the array is a means to speed up the processing, right? So we have persistent storage here, the books.json. When we are searching, we are not trying to, because we have loaded the data in the array, it's in memory. Every time reading and writing or accessing data from the physical storage is going to take time, right? So what we do is normally we use the in-memory database or the RAM of the machine to speed up those queries, right? So in this case, what we did is, even though previously we were using arrays, When we read the data, we just put it in an array just for fast access, fast update, but eventually the data gets written to a persistent storage, which is books.json in our case, which I hope makes sense. We could have totally skipped the array, but what would then happen is every time there's an update needed, we'll read the file again, then at least we have to store it temporarily somewhere while we are finding through the correct book ID, right? So that's why that array kind of helps us as a supporting mechanism, not for data storage, because once the program ends or terminates, all those data will be lost. So our persistent storage is books.json. So after every update, search or whatever, we kind of update the persistent storage as we go along. Okay, and there's another interesting question which we will answer in the second half of the lecture. We tried to solve one issue with generating the correct book ID. So when we did a post, we looked at how many books are there, -1, and then whatever is the ID of the last book, we added it by 1, right? Now that would work in a lot of scenarios, but it will not work in one particular scenario, which is that.
If you don't add the objects to the end of the array.
Yeah. So what will happen in that case?
Well, then it'll duplicate the ID if the last one isn't the highest ID.
Yeah, but as per the current implementation, if the array has some element, it will find the size of the array, extract that element, get the ID value of that element, and just use the next one, right? So every time it uses the last element in the array, usually, and increments the ID by 1. Now the problem will happen if the array is totally empty, then you have no elements to look at, right? Now that is an exception condition, and we'll look at how we handle that in the next part shortly. But that's a good identification of an issue. Yep. Yeah, another important thing to note is, whenever the saver starts again, right, we're looking at this books scenario again, we load all the item from the persistent storage into memory, right, so that the rest of the function calls or endpoints are able to quickly search through that. We may not require that, right? What we could have done is read it each time under each endpoint. For example, when we want to update something, read the file and then update and then write it back to the file. So that would mean reading and writing multiple times, right? So whenever you get, forget, we'll actually replace it with the read function. But when we are reading it again, right? Just to make sure we have the most up-to-date books listing. Yeah. So we're not relying totally on the arrays for the updates. It is helping us to speed up updates, search, and so on. But we're actually relying on the data that is actually in the JSON file. So every time, even if you want to delete something, we read it first from the file, use the array as temporary storage to splice that entry, and then write it back to the file, right? So array is basically a structure that's going to support that process, right?
explain why you need to splice it?
Okay, so we want to delete a book, right, with a particular ID, right? So first of all, we try to locate the book using find index, right? Where the index matches, we find that book. And basically splice means if an array had 3 books, right? So in this case, let's assume it's an array, so it's just 2 books. And this is the book we wanted to delete, right? So at index number 1, this is index 0, index 1, we splice this one entry. So that's what splice is going to do. And it automatically readjusts the array. You don't have to handle it like you did in COMP1511 where you can't resize. Yeah.
So it indexes to a specific point in the array. And
Pointer to where that particular ID was found. So it just returns that. And then the second parameter pretty much is how many entries do you want to get rid of from that point onwards? So 1 means splice just 1 entry. Sometimes you want to splice the next 5 records maybe, right? So you can use 5 as a parameter. Okay, so I think we can move to the next part now. Okay, which is code coverage. You must have seen this mentioned many times before, right? What do you think is code coverage?
the integrity or how if you consider the side effect or edge cases of your code. I don't know.
Yeah, I mean, there is some linkage between coverage and testing, right? So we use testing as a mechanism to identify or understand code coverage, yes?
is coverage like how much finding out like what exactly our tests cover and what they don't cover?
Yeah, so in short, coverage is basically a measure of how much of your code is actually tested by your test cases, right? It doesn't actually mean that if your coverage is 100%, then all your code is correct, right? But if it is less than 100%, if it's suppose 50%, it means your test cases are not sufficient to consider all the different scenarios in your code, right? So whenever you push out a code for production, you want it to be tested, right? So coverage becomes a mechanism to help identify how much of your code has actually been tested. Now companies normally, many of them have a threshold. If you as a developer are working on a part of an application, you might need to reach a coverage of about 80-85% before you can submit it to your team leader or your team for merge requests, right? So there can be certain ground rules, formal or informal, that can be set. Of course, if someone says how much is your code coverage and you say, oh, 10%, that means you haven't tested enough, right? And it's very risky for a production system to then accept or adopt your code. So coverage is an important metrics in terms of how much of your code has actually been tested properly, right? So we'll, in this next maybe 20 to 25 minutes, we'll try to understand what mechanism we use that can tell us some measurements for code coverage. In simple, you can say coverage is out of all the code that you have written, how much of my tests actually check that code, right? So we'll focus on coverage. There's another term called code coverage, and then we'll look at how coverage can be implemented using Jest. Right? There's some theoretical things. So coverage basically is a general measure. There's 2 types of coverage, test coverage and code coverage, right? So let's just open one of these files, right? So this is a quite relevant example. What we are trying to see is determine someone's grade from the given score, right? So there's a function grades.ts, right? And if the person scores less than, so it accepts a parameter, which is a number, and now it has a return type as a string, right? And it's important because it can then help us write our test cases. So we are comparing string with string, right? So we actually have an idea of what to expect. So if it's less than equal to 49, the grade is FL for fail. Less than equal to 64, it's PS. Like I said, I'm a bit new to University New South Wales, so the grading structure is different from my previous university. Does this look correct? Yeah. Yeah. Have we considered all the cases? I mean, there are special considerations and other things, but are these the main scenarios? Yeah, okay. Now, let's look at our test, right? So what I've done is, because I've exported that file, that function, I can import it here in my test file. Now, I want to test HD cases, right? So my code would be expect, and what should I use here? The function, grade from score, and which value you want to test? Let's pick an edge case. Will 85 be HD? Right? We can use 2b or 2 equals. This will work fine for majority of the data types, string, number, boolean, and so on. Someone asked me about that. Why did we use 2 equal in another lecture and 2b in a different lecture? They both work fine. 2 equal basically works, is more preferred for string, numbers, boolean. 2b can also work for arrays and other objects as well, right? Yeah.
Should we not use like two strictly equal, or
Huh?
is it better to use like two strictly equal, or is two equal?
You can use that, right? Just for demonstration, we'll just keep it simple, and then let's put HD. Right? Let me just have package.json. Let's not use the coverage flag yet. Right? Now, if I run this test case, npm run test and grade.test.ts. Right? So it passed the test. That means this has checked for that particular case. If I comment that, right, and then now I run my test again, it still passes the test. Right? What does this mean? Yes? Okay, so there wasn't any issue identified in this test case, and that's why it said there was one test case in there and there was no issue, so passed. Right? That means if you do this in your assignment and exams, you can pass and get 100% of the test, isn't it? Well, if you just use this approach, maybe, but that's why we don't encourage this. That's why we want to focus on test coverage, right? Now, if I suppose test for, another case, this time for dn, which is 74 to 84. Okay, so dn cases. So let me use this. Okay, so it's passed 2 tests because I have 2 tests successfully passed, Is this sufficient now to submit for a merge request and go on our production system? No. Why? Because we haven't considered all the cases, right? So that is what test coverage is, right? Test coverage is a measure of how much of the feature set is covered with test. This is often left to human judgment. Now, when we mark assignments, we use test coverage plus code coverage. So test coverage is done by a human, right? It's their judgment, and just like you judge that, oh, that was not sufficient, right? Here, we can see that your approach is called test coverage. Code coverage is a measure of how much of the code is executed during testing, and this can be computed and quantified using scripts. So the code itself can also identify which line was hit and which one was missed, right? And how can we do that? If I just go here and just go to package.json where I define where my jest is located or how I run my test, I just put the flag dash dash coverage. So instead of doing a normal test, right, which is giving me 100% pass, which is very misleading according to your test coverage. Let's see what the code coverage tells us now. Right? Now this makes more sense, right? So not everything is 100%. You see that it tested only grade.ts file. In terms of the functions, right, how many functions did that file have? 1, right? So 100% of that was tested, the function itself. However, you see that there are some uncovered lines, 3, 5, and 7. So you haven't tested line 3, this fail case, this pass case, and this credit case. Yes?
We will have access to this in the exam as well, like where
Yes.
and we can get to know what exactly cases you have tested in the test.
Yes. Yeah, you will have access even to the API documentation of.
I wanted to ask you that how can we like be sure that we've covered all test cases in that system?
Yes, so you'll have access to that. Yeah. Yeah, and then you'll notice that apart from that, there's a folder that's generated here, right? It's called coverage folder, and we'll go into the detail. It gives you a report, right? So in your assignment, as well as in your actual exams, we can always refer to that folder and see the report about your test coverage. So we'll look at it shortly, but you see it comes up with a number of metrics. It says 70% of the code was executed. So if you count how many statements were executed, if, else if, whatever, 70% of them were executed. Branches, anyone knows what branches are? I mean, not in the context of Git, but in the context of our normal program. Yeah? No.
If you have like an if else, like how
Yes, so if else condition, different pathways you can take in a program, right? So in a single, most of the code we write is sequential, but sometimes there's a decision point, so there's 2 branches. And sometimes your script only tests one particular branch, right? In this case, we only tested 62.5% of the branches, right? 70% of the lines, right? So we'll look into it in more detail as we go along. Sorry, why is this opening all the time? Right? So what we just saw now was code coverage. The feedback you gave me was test coverage. So when someone talks about coverage, it just means a metric, right, of how much of your code is executed during testing. And there are 4 different metrics that Jest provides. Can you recall them? Branch, right? And why is using the branch metrics useful?
it typically matches.
Yeah, because we normally go for the most ideal cases and test the most ideal cases, but you don't know how the end user might interact, how they will interact with your platform, right? So they might type a null password, right, or no username. In your understanding, the user has to type a username and password, but there are a lot of different variations that can happen, right? Password with no username, username with no password, right? Or maybe where you expect them to enter a number, they'll enter a string, right? So those are different branches that you have to consider using if else or other conditional operators. So branches are important. The other one we saw was the statements, right? So how many statements are in your code, right? Which can be variable declarations, if conditions, and so on. Then number of lines, right? Now number of lines is a bit controversial also, because if we use maybe the thread method using arrow functions, maybe 4 or 5 statements get condensed into one line, right? Your function declaration, definition, return, all those things get compact into one line, right? So it might pick up 3 statements, but it will just have one line. If you use method 1 where you have a function name, then you have braces and other things, then it will say, oh, multiple lines were executed. And what's the other one? Number of functions. So suppose if this code, this particular file currently shows 100% of the functions were executed, you put another, you put another function here, function I, which does something, right? Now you run, you see the functions coverage is now 50%. So 1 out of 2 function from that file which you were testing has been executed only. So it gives you an idea of whether you are testing all the functions that you have written, or if there are some redundant functions you can get away with, right? So that's also something worth considering. Right. So this is just an example of how you can do coverage in Jest. So just use that flag, and then you should be able to see some detailed metrics apart from how many of those test cases succeeded. You'll see statements, branch, functions, lines, and so on. Right. Now, apart from that, you can also see a report. So in the coverage directory, you'll see there's a LCOV report, right, coverage report, which is more useful than what we see here, right? Because, for example, this is the directory I'm saying coverage LCOV report, and inside that you'll see there's an index .html file as well. So let's just run that file. Let me clear the screen so you can see what I'm typing. So I'll do open coverage directory LCOV report index.html, right? So it opens a web page, right? Same information here, but when you click on that, it gives you a sense of how many times each line of code was executed, and it highlights for you, right, in red, right, which lines were not tested yet, right? So your idea is get rid of all the red and make it all green, right? That means you have done sufficient testing, right? Even it highlights this particular function as well, which was not tested by a script, right? So that's the general idea about coverage. Any questions? So it's not a difficult concept. It's only you just have to ensure that you understand the metric and you are able to go back and fix up your test cases. Like for me, right, we'll do that to this particular file, right? We already talked about branch checking. We also talked about this already, right? Statements, percentage of all codes that are there, it's on the slides just for your reference, what these different metrics actually mean, right? So let's see if we can reach 100% coverage and 100% for our example here, right? So I've written some test cases at the bottom. You'll also find it in your file, which kind of checks pretty much everything in there. Right, so I'll save that. I'll just tidy this file because this is not very relevant now. So what I'm doing is basically the same thing, testing HD cases. I'm just using 2 examples, DN cases, FL cases, pass cases, credit cases with 1 or 2 examples each, right? And let's just run this. Sorry, I choose the wrong script. Right? Everything looks 100%. Right? That means I have tested all the different branches, all the lines of statement. If suppose I get rid of one branch, right? Let's see what happens. Okay, 87.5%. Right? That brings us to the question, right? How many branches are there in this line of code? Right? Because only then we'll be able to understand how this is calculated. Right? We know that line 11 was not executed, so a HD case was excluded in the test, which is correct. I commented it out. Right? 90% of the lines, if you count the number of lines here and divide it by the ones that excludes HD, it will be 90%. Statements, because it's written linearly, I mean one statement per line. I could have shortened it up using this way, right? You can write things on the same line. It would have given a slightly different value then, right? But we'll leave it to that. More important is the branch. How many branches are there? How many decisions are being made? How many decision points are there? 4 decision points, and each has 2 possible routes, right? Which means 8 branches, right? And we tested 7 out of 8, which is 87.5%. That's how we get that value. Right? Now, in some code, you may only have a if, right? If. So there's no alternative. So some people just check one at a time, right? If this, they don't have a else if. They'll put another if, another if, another if. So the number of branches will then vary, right? So just keep that in mind. Can be useful for your exams, right? Getting to know how to calculate the number of branches and manually come up with your code coverage by looking at a test case presented to you. Yeah, like I said, that's all coverage is about, and coverage is actually useful, right? More useful than just your normal test cases. But remember, 100% coverage does not mean your code is foolproof. There's still problems in that code. Although I have tested it, what are some of the issues? You'll notice in the implementation, we are assuming only data that is between the range 0 and 100, right? If someone enters -5, how will the code respond? If someone enters a string, how will your program respond? Right? If someone enters 20,000 as a mark value, which is not possible, right? So these are extreme cases which are called exception cases, and that's what we'll now focus on after we summarize coverage, right? So it's important to look at coverage, but also important to be mindful of not just code coverage, but test coverage, which means human input into what is being tested and what scenarios are not being tested. Now, if you want to know more about software testing, there's also another course in the faculty which you can take. So we'll not go into too much detail. At this level, I think you have sufficient knowledge about coverage and how to interpret those metrics for your assignments and to build a reasonably sized software application, right? Even work in a team in a real life situation or industry situation. So that's on coverage. Any questions? Yeah? No? Okay, we'll take another maybe 15 minutes just to look at a few exceptions that can occur. Okay. So normally, we know that your programs do run when we enter valid values, but how should your program handle invalid values? If someone does not enter any value for username and password, how does your code react for your application? Crash?
Should crash, but if we don't have test cases, it will crash.
Yeah. So in most cases, if you don't implement any mechanism, it will crash, right? Which is not acceptable, right? In a real world situation. Suppose you try to log into Facebook, invalid values were passed in as username, password, or maybe nothing, and then the whole server crashed, right? That's not ideal. We look at particularly in JavaScript how we can handle these special kind of cases. And then when errors or these exceptions happen, how can different functions actually raise or throw these errors? And then whoever initiated that call, right, or provided that incorrect value, how does that part of the program actually catch that error, right? And then X on that error. Okay? Like you said, the simplest way to deal with program at runtime, just let it do whatever it does, and you let it crash, right? In other, maybe in your COMP1531, what you do is just return 1, right? When you return 0 in C or C++, it means successful execution. But if you do return 1, the program just stops, right? The process stops. So here's the great example. Same implementation, only thing is we are reading input from the user. At the bottom, there's some scripts, right? And pass it as a number. And if the number is less than 0 or greater than 100, or maybe it's not a number, it couldn't pass, it will just stop, right? So that's one way of dealing with the program. Right? The other way is you let someone know that there's a problem, right? So whoever actually sent that number, because there can be different clients, it can be a mobile app that was trying to log into the Facebook server, or it was a web browser, right? So what the server can do is throw that exception. Let the client know that you have sent me invalid values, right? So option 2 with dealing with problem is not just crash and burn, you try to throw that exception, right? And when we say throwing exception, it's a new territory of programming because in C, we don't have exception handling, right? You have to always look out for exceptions and implement that in your conditions, right? But in higher level programming languages, Java, C++, we have Python, we have JavaScript, they have exception handling. Right? So what are exceptions, right? So the universally recognized definition would be an exception in programming is an event which kind of disrupts the normal flow of the program, right? whatever the expected input was, it maybe probably isn't that, and thus it results in an error, right? Very common types of exceptions come from invalid input and also from missing files, right? We try to reach a file or you try to read a file and the file doesn't exist at that location. Maybe it was moved, it was renamed. So these kind of situations are very common and can cause an exception. And maybe the best way to handle is to recover gracefully. Let the user know or terminate such that you don't kind of crash the entire server, right? One of the concepts in JavaScript and Python in terms of handling exception is the concept of easier to ask for forgiveness than permission, right? So what you do is take a subtle approach. You try to do something, right? If an error happens, you are telling this other function that, yeah, you can throw the exception, I'll catch it and handle it accordingly. Right? So you take responsibility, and what you do is you you enclose your program in the try block, and then if an error happens, right, you will catch it and you handle it. Okay? The good thing about this way is, for example, what is happening here is you are reading a number and you're passing it to a program, right, a function, and then trying to display the grade. Suppose if that number is out of range, you are not implementing a lot of conditions like if number is less than 0, it's invalid. Greater than 100, it's invalid, right? What you're doing is just merging or combining all those invalid scenarios together by using the try block. Right? And what it does is it simplifies the main logic of the code, and you don't have to handle multiple error types, right? Different data type errors or out of range value errors and so on. But the cons of that is you can't sometimes give specific feedback, right, on the error. It makes the code a little unstructured, and also it's harder to reason out what code will be actually executed. This is one way we could handle errors in JavaScript, right? So we use the try catch. The other way is you look before you leap. This is the approach that you must have seen in C, right, and many other programming language. It does not require you to look for exception. It requires you to check for all those edge cases yourself, right? Something like this, right? If file does not exist, then you display the error. So you're handling all the exception as a programmer yourself, right? You're not leaving it to the compiler or not enclosing the situation using the try catch block. Now, which approach will we adopt in this course? We'll use the simpler approach. We'll rely on the easier to ask for forgiveness than permission approach. That means we'll use the try catch block. We don't have to always check for specific type of exceptions, right? So just to do a demo before we round up exception handling, how it actually works. 5.4. Right, so we look at the first type, which doesn't, which uses the process.exit, right? More like return 1. So it basically exits the application. If you use this, right? It asks for me to enter a score. If I enter a valid value, works fine, gives me the grade. If I enter a value out of range, right, it gracefully just sends me the message score must be between 0 and 100, and then just ends the process. So that's one way of actually handling exception, which maybe you are more accustomed to. And there's no harm in using this way. The second way is you don't take responsibility for the exception, right? You just throw it to whoever actually sent you that invalid input, right? So what you'll see happens here is when I try to run this code, right, I'm reading the person's the mark, and I'm calling that function grade score, right? This function takes that value. If it doesn't meet its requirement, it just throws it back, right, that error. And I have to catch it and display the message to the client, right? So this function basically just throws that error. Enter score, if I say 89, HD, enter score 899, error, right? Now this is the message that it threw. Right? Now if you look at the error object, the definition, it has the name, the message, and the stack. This value that I have provided is the message. The name is basically just error by default, right? So it's just passing it back to me. It's not handling the error. When I say not handling the error, I'm not saying it's not checking for the error. Handling means how it responds to the error, right? So it just throws the error message. This calling application has to handle the error. And what do you think this program does, or this part of the code actually does? It just displays the error, and that's it. Right? So that's one way you can let the user know your password is incorrect. But that's not how applications work, isn't it? You log in, your password is not correct, what do? You give another chance. Right? So here's another example. Right? Again, throwing the error. Now the calling program, right, or the calling code actually sends that. When it gets the error, it gives the user another chance. So that's another way of handling the situation, right? Rather than gracefully exiting, you are not exiting the program, right? You are still running and you are asking the user for input, right? So this time it's exception 2. Okay, enter a score. Suppose I enter 999, which is out of range. Error, enter your score again. Now I'm trying to be very smart. I put -10. I crashed the application. So even this is not useful, isn't it? So it gives you one chance after that, and then it doesn't handle it appropriately. So what would be the ideal way? How do normal systems handle error or exceptions? Okay, you encounter exceptions every day. You mistype your password. Right? How do the application respond? Restarts?
Or like hasn't asked you to do the same thing.
Yeah, it gives you another chance, right? And gives you multiple chances again and again. Now some applications for security reason may give you 3 chances and lock you out for maybe 60 minutes, right? But then they don't crash the server, they don't stop the login form, right? They just handle it in a better way. So that's what we are trying to do here now. Right? Instead of crashing, try to see what this code now does. Right? It uses a looping structure while, and initially it's false, so while true, while not false means true. So it goes in, it gets your score, right? If an error happens, it catches it and displays it, right? So that means this part doesn't execute, right? An exception was encountered here when this function was called. So it can't come here, program tries to crash, but it throws an exception, you catch it, display, and then go back again. So you keep trying until this line executes successfully without any exception, which means then the success status is set to true, and then your program terminates, right? Okay, you can take some inspiration from here. Right? So enter score -3. Enter score, you put S, still ask you for input. Enter score 998. So it will keep asking you until there's a situation where you enter a valid value and then it will give you the result. Right? So you have a choice of how you want to handle exceptions. Remember, there are some applications where you can't use a forever loop to keep giving more chances to the user, right? And there are some applications where you can't just give them one chance, right? And there are some applications where you can't just stop the server totally, right? So keep that in mind. Right? So these were the 3 examples we looked at. Now this is using testing your exceptions using jest. We'll just quickly demonstrate that. We have 6 minutes left. Now this can be quite useful for you because how do we test for exceptions? So we'll use this one, this example, right? So what it does is it just throws back the exception. You want to test some scenarios for this. I will comment the try part because my input will not come from the user now, it will come from this file, and I'll score the valid categories of grade, and then I'll test the invalid categories of grade, right? Now just because it's a different doc folder, okay, I have the coverage set on. Go back to catch.this, I clear the screen, I do npm run test, let's see, catch test. Okay, so it's running the test, all tests are passed and everything works fine, right? Which is fine because everything that's written there is as per what it should be, right? I've tested all the cases, and here I'm also testing outlier cases or exception cases as well in a different test suite here, right? So in the second one I'm testing this, deals with invalid score value, and then the exception it's throwing is this. See some differences between these few lines here on top and when we are handling exception. One is you're not checking for equality, because what that line of code will do is throw an exception, which is this particular message. And what you are doing here now is checking if that message is actually thrown by the function. So that part should be straightforward, right? Now what is different here is this part. If you look at this line of code, I have used an anonymous function. The question is, why can't I use something like this, right? So I'll just comment this part. This is what was used. Why can't I just use grade 120? Just like we have used it here, right? If I use that, and let's just see the output as well. Test has failed. Now, why do you think that has happened? Yeah.
It's not like it doesn't check for what it returns.
Yeah. So, I mean, generally you are in line with what the reasoning is. So, what is happening here, if you call it this way, is it uses the return value of this function, right? And then tries to compare it with what was thrown, right? Now, do you think this function will be able to return anything? No, because it's an exception case, right? So you can't actually compare, because it is trying to crash the program, and that's the reason why it crashed your test as well, right? It failed your test. So it's returning some kind of exception which actually didn't let your code to fully complete, and that's why comparing that to this is not possible. Now, if you use an anonymous function, what you are doing is, instead of using the return value of this function, you are passing a function into jest, right? So what jest does is takes that function and tries to run that function. When it tries to run that function, jest already has built-in try-catch mechanisms in there, right? So if it captures that exception, it uses what is captured, right? Because it will succeed because it's within try-catch statements to compare with whatever is thrown here, right? So when you use this anonymous function, you pass the function through jest. What it does, it runs that function, and we know that that function will succeed because jest is running it using its own internal try-catch framework, right? However, when you are running this call, it cannot succeed because there's no catch or try framework for this one, right? It just throws you an error, and then it can't actually complete the entire function call, right? So that is what is happening. So just be mindful of that. When you test exception cases, where possible, you can use anonymous function. Now, if in some cases the functions are big, right, this function is same as, let's say, const my function, right, something like this. So this is what that is equal to, and then you can just use this here, right, and then it should work. Right, so it works. Now, if this works, that means even this should work. Sorry, my function here, right? I can get rid of the arrow operators. This should work, right? And this should be a function. Yeah. So even that should work, right? It's the same thing. Just the expanded form. And if you have multiple lines of code, then that should still work, right? So that shouldn't be a problem anymore, right? So just be mindful if sometimes you directly call the function within the exception scenario, it might not complete the execution and therefore give you errors, right? So pass them as an anonymous function and it should be fine. Yeah, so that's pretty much it. There's this 30 seconds of your time I would need because this might be later on useful for your exams. Now, exceptions are usually problems in a program. Now, as a user, you'll encounter or programmer 3 types of problem. One is compile time errors. So these are the ones that you catch before you actually execute. It won't let you compile a program, right? So sometimes issues with syntax, variable names, data types, this kind of code won't let you compile. So this happens before. There's runtime errors, where when they run, it might give you some error situation. For example, values out of bound and so on. To solve them, you can use try-catch. And the third one will kind of escape the first two scenarios, but it will give you invalid values, right, or invalid results. For example, if by mistake I change the boundary for HD, then students will incorrectly be given a wrong grade, right? So that becomes a logical error. So that's the summary for you there, the different types of errors. Make sure in your projects you are mindful of all these types of errors. And that's it for today. Thank you very much. If you have any issues, you can reach out to us. We'll be able to help you next week as well. But note that next week is Flexi Week, so there will be no classes. So we'll see you in week 7. Thank you.